Today we are going to quantify brick masonry. First we calculate volume for brick masonry and then figure out number of bricks. Later on we calculate cement bags and sand for a particular mortar.
Hey everyone, welcome back to Civil Builders. I am Engineer Arsalan.
The methodology for this video is simple and practical. Plus we extract dimensions directly from drawings. Next we plug those values into Excel and apply simple formula to perform calculations. Finally, we switch to Revit to automate the process and compare the results between Excel and Revit. Let's review architecture drawings. From the floor plan, we got an idea of exact location of the walls, its type, and the thickness. For thickness, we have to use the command dim. The thickness of this wall is 4.5 inch. And similarly, you can find out the thickness of another wall. That is 9 inches. For the depth, we have to move toward the section details. Here we have to provide the walls from the base to the top, and the dimension is 10.5 inches. Let's come to the Excel workbook and perform calculations. So here we are going to calculate the brick masonry for first floor. VR stand for brickwork and 9 inch stand for the thickness, and 1F shows the first floor. The thickness of this wall is 9 inches and the depth is 10.5 inch. To find the length, we have to review the floor plan. Firstly, I perform the calculation for these 9 inches wall along the x directions. For the length, we have to use 60 feet. After performing the calculations, we have to predict these windows. So I have 60 feet in the length column. For the quantity, we have to multiply the dimensions. In the number column, add 1. And for the total quantity, we have to multiply the number column with the quantity column and drag this formula. Next, we quantify brickwork for the remaining walls. To find out the length of these walls along the y direction, we have to add the thickness, because 40 feet is the dimension from this column to this column, but we have to add the thickness of this wall and this wall. And after adding the thickness to these dimension, our exact dimension is 21.5 feet. Put this value into the Excel workbook. And also add the remaining values. Drag the formula. Add 1. We have calculated the external wall. Now let's jump to the internal walls. In the internal wall, we have just 1 9-inch brick wall, and its length is 5 feet. All the remaining walls are 4.5 inches. The length of this wall is 5 feet.
and the thickness is 9 inches. The depth of this wall is 10.5 feet. We have already applied the formula, so automatically calculate the values. Repeat the same steps for 4.5-inch wall. The thickness of this wall is 4.5 inch, and the depth is 10.5 feet. And the length of this wall is found by using the dim command in the CAD file. That is 33 feet and 9.5 inches. We have estimated the brickwork for this 4.5-inch wall. Now let's calculate the volume for these two walls. The length is given here, that is 6 feet, 6 feet, and 5.5 feet. To sum up all these values, 17.5 feet. In the same way, we quantify the other walls. And all these values, 6 feet, 11 feet 10 inches, 10 feet 3 inches, and 4 feet 4.5 inches. Adding the length of these 4 walls, we got 32.625 feet. And the length of this wall is 5 feet. To add all these values, we have to use some formula. Select the range of the cell and close the brackets. Next, we are going to calculate the deductions for doors and windows and for this RC wall. Let's jump to the CAD file and calculate the volume for these deductions. The dimensions for these windows for this rear rod is displayed here. Now let's input all these values to Excel workbook. And the thickness of this wall is 3.75 feet. The reduction volume for the rear window is calculated. Now let's repeat the same step for the remaining window at the rear wall. Count the windows 1, 2, 3, 4, and the dimension is 6.5 feet, and the depth is 7 feet. Drag the formula. For the reductions, add negative sign. Similarly, calculate the reduction for this front wall. Jump to the front elevation and check the dimensions of these windows. And input the values into the Excel. Next, we calculate the reduction for the side walls. The length of this wall is 7 feet, and the depth is 9 inches. and the height is 10.5 feet. As there is only one wall, so we add -1 in the number column. Lastly, we do the deduction of doors for this internal wall. Count the number of doors. 1, 2. Input the values. The length of the door is 3.5 feet and its height is 7 feet. And the thickness of this wall is 4.5 inches. Count the number of doors for these baths. There are 4 doors, also 2.5 each. Also detect this opening. After detecting the values, the volume for the brick masonry is 1788 cubic feet. Now let's proceed further by calculating the number of bricks for this required volume. In our project, we have used brick having its length 9 inches, width 0.25 inches, and the depth 3 inches. To calculate the volume, we have to multiply all these two dimensions. After multiplying, we got 114.75 inches. Well, to convert this value into cubic feet, we have to divide it with the number 1728. Let's calculate the brickwork quantity in 1 cubic feet. We have to use the formula listed above. By inputting these values, we get an answer of 50. That shows us that there are 15 bricks in 1 cubic feet. On site, we have to apply mortar between the different bricks to interlock them. This mortar is basically a paste of steam and sand and water. After applying this mortar, the length, width, and depth increases from 9 to 9.5 inches, and the depth increases to completely 3.5 inches. The new volume for the brick is 0.0817 cubic feet. After applying the mortar, the number of bricks in 1 cubic feet reduces from 50 to 13 cubic feet. Moreover, let's start calculating number of bricks and mortar required. Input the values of brick masonry that we have recently calculated. And for the volume of bricks, refer to the brick volume sheet and select the volume in cubic feet. For brick calculation, use this formula. Type equal to and select the brick masonry volume and divide with the volume of the one brick. Now let's add wastage to this brick masonry. Add both to get the total number of bricks. Next, we'll perform mortar calculation for these bricks. For mortar, we use 1:5, where 1 represents cement and 5 represents ratio of sand. For the mortar volume, we use this formula. We have to multiply these number of bricks with the mortar required in each brick. To find the mortar volume, instead of quantity of the volume, we have occupied by the mortar equal, and then subtract these volumes. This is the mortar volume occupied by each brick. So to find a required volume for these bricks, I have to multiply both. As this is the wet volume, so we have to convert this volume into dry by type equals and then multiply it with a factor. Next, we'll find out the cement bags and sand for this volume. For cement volume, we have to use this formula. Type equal to and then select cement ratio, divide it with the total ratio, and multiply with the volume. Next, we do some cement bags calculations. So for that purpose, we have to again divide this volume with 1.226, where 1.226 represent volume of cement of one bag. Similarly, do some calculation for sand. Select the sand ratio divided the total ratio and multiply it with total volume. Till now, we have to some brick masonry calculation, number of bricks, and cement bags and sand per particular mortar. Well, let's head on to our next section where we perform calculation using Revit. First, we quantify the brick masonry, and then we'll figure out cement bags and sand requirements. So let's open the Revit screen and navigate to the View tab. And from this Schedule drop-down, select Schedules and Quantities. And from this dialog box, select Walls. And click OK. A new window pops up. On this window, select the required parameters like mark. To shift this parameter to the right side, use this arrow. Similarly, shift the other parameters. We can change the order of this list by using these arrows. Here C represents cement ratio and S represents sand ratio. Add a new calculated parameter for adding the ratios. For cement bags calculation, we have to use this formula. Add this formula in Revit by using a new calculated parameter. Click on this Add Calculated Parameter and rename it as cement bags. And add the formula and click OK to apply. Same way, add the calculated parameter for sand. Add another parameter like work set. And now click OK to apply. Do some formatting to this table. We can change the name by simply typing. We can easily manipulate the properties of this table via the Properties panel. If I want to add the grand total for these columns, for that purpose, I need to go to the Sorting and Grouping and check this grand total option. Here I got the total value of all these entries. To display the grand total of volume, cement bags and sand, again go to the Formatting tab and select Volume, cement bags and sand, and check Calculate Totals from this drop down and click OK. By applying this setting, the grand total is displayed in this table. Now let's filter the unwanted data. From this Filter tab and use Work Sets. And click OK to apply. We can also add coloring to our table from this Appearance tab. Select the color from this window and click on this Strip Rows and click OK. We can also separate this table based on the wall thickness. For that purpose, go to the Sorting and Grouping And from this drop down, select width and click on this footer options and also blank line and click OK. In this way, our walls of 4.5 inch and 9 inches got separated. That's all for today's session. In the next video, we'll proceed further. Make sure to like, share, and subscribe. See you in the next video.